Your engine can be misfiring right now, and your check engine light might not even be on. There is one part hiding in your engine that silently destroys everything else. It kills your spark plugs, it fries your ignition coils, it makes your fuel injectors look broken, it corrupts your sensor signals, and it does all of this without ever triggering a warning code. Mechanics say this single part causes more misdiagnosed engine problems than any other component in your car. Yet 99% of drivers never think to check it. Most people replace spark plugs, they swap coils, they pour fuel cleaner into the tank, they throw hundreds of dollars at the problem, and the misfires keep coming back. Why? Because they are chasing symptoms, while the real cause sits there silently making everything else look broken. And here is the scary part. While you are chasing misfires, unburned fuel is flooding into your exhaust and slowly destroying your catalytic converter. That repair can cost $1,000 to $3,000. In this video, I am breaking down 14 engine parts that silently cause misfires. We are counting down from number 14 to number 1. But here is the thing. The part at number 1 is the one that makes all the other parts look guilty. It is the silent killer mechanics see over and over. Stay until the end, because that number 1 reveal could save you thousands. Quick warning before we start. If your check engine light is flashing, stop driving immediately. A flashing light means severe misfires are cooking your catalytic converter right now. Now let us start the countdown. Coming in at number 14 is the intercooler. This only matters if you have a turbo. Most people think about spark plugs or coils when misfires happen. Nobody thinks about the intercooler. But in turbo engines, this part quietly collects water and oil that cause big problems. The intercooler sits between your turbo and your engine. It cools down the hot air from the turbo before that air enters the engine. Cooler air is denser. Denser air means more power. Sounds great until you understand the problem. When hot air cools down inside the intercooler, water droplets form. That water mixes with oil vapor from your crankcase. Now you have oily water collecting in there. Eventually, it gets sucked into your cylinders. It fouls your spark plugs. It contaminates your mass airflow sensor. Your engine goes lean, and it cannot fix itself. The symptoms are frustrating. Misfires that only show up when you accelerate or boost. At idle, the engine runs fine. Push the throttle hard and misfires appear. Let off and everything goes back to normal. Ford EcoBoost owners know this problem well. The fix usually means draining the intercooler, checking clamps, and fixing PCV issues. If you have a turbo, test the intake pressure at full boost. That is the best way to find leaks. But even if your car does not have a turbo, there is a part you have probably replaced before without thinking twice about it. When this part wears out, it silently destroys your ignition coils long before it actually fails. Number 13 is the spark plug. Before you skip ahead thinking you know this already, there is something most drivers never learn. A worn spark plug does not just quit one day. It slowly kills your ignition coils first. The spark plug makes the electric arc that lights the fuel in your cylinder. As the plug wears over thousands of miles, it needs more and more voltage to spark. The gap gets wider. The edges get rounded. Now your coil has to work way harder than it should. Here's the expensive cycle mechanics see all the time. Worn plugs stress the coils. Coils break down inside. You replace the coil. It works for a while, then it fails again. Nobody realizes the worn spark plug was killing coils the whole time. You can read your spark plugs to see what is happening inside your engine. Pull one out and look at it. Light tan deposits mean healthy. Black soot means rich mixture or weak spark. Oily coating means oil is getting in the cylinder. Wet fuel means the plug is not firing. White blistered tips mean overheating. Not all plugs wear the same. Copper plugs wear fast. Platinum and iridium plugs last longer because the tips hold their shape. But turbos, performance driving, oil burning, and short trips all shorten plug life. When you install spark plugs, do it right. Work on a cold engine. Hand thread first to avoid cross-threading. Use a Torca wrench. Too loose causes leaks. Too tight can crack the plug or seize it in the head. Plug gap matters too. Gaps wider than about 45 thousandths of an inch can misfire under high pressure. This is why turbo and high compression engines use smaller gaps. Do not adjust iridium or platinum gaps unless you have to. The fine wire tips break easily. One thing that surprises people. On some Toyota Camry V6 models, you have to remove the whole intake manifold just to reach 3 plugs. What should be simple maintenance becomes a big job with a big shop bill. When facing this, replace other wear items at the same time since you are already in there. Now, spark plugs create the spark, but there is another component that works hand in hand with them. When this part fails silently, it can destroy brand new spark plugs within weeks. That brings us to our next silent killer. Next up at number 12 are ignition coils and spark plug boots. Coils turn low battery voltage into the high voltage your plugs need to spark. No healthy coils means no spark. No spark means no combustion. Most drivers do not realize coils can fail silently for months before setting a code. Internal shorts develop over time. Heat breaks down insulation. Oil from leaking valve covers damages the outside. Rodents chew wires. Water gets in connectors. Even a weak battery or bad alternator can stress coils. All of this kills coils in different ways, from obvious to barely noticeable. Watch for these warning signs. Hesitation when you accelerate. Hard starting. Rough idle. Subtle vibrations. Some coils work fine cold, but fail when hot. Others fail in cold weather and work better warm. To diagnose, swap coils between cylinders and see if the misfire follows. Do a nighttime inspection looking for sparks jumping around the boots. Mist water on suspect areas to reveal weak insulation. For tough cases, an oscilloscope shows what basic tests miss. Honda Civic owners often report idle misfires that go away when they hit the gas. This usually points to idle controls or valve adjustment, not coils. Civic forums also show cases where wrong aftermarket plugs caused misfires that stopped when factory plugs went back in. Toyota Camry owners across many model years have learned this lesson the hard way. What looks like multiple coil failures often turns out to be blown EFI fuses, loose ECM connectors, or bad grounds. Always check fuses and supply voltage before replacing coils. One 1995 Corolla had RPM drops whenever electrical loads kicked in. Everyone suspected the coils. The real problem was the alternator and battery struggling under load. A 2006 Prius with recurring coil failures had another surprise. The hybrid battery was also failing. It took both coil replacement and battery module testing to fix it. The spark plug boot connects the coil to the plug. Boots crack over time and let electricity arc to ground instead of reaching the plug. Check for cracks, carbon tracks, and oil contamination. When one coil fails, should you replace all of them? If your car has high miles and the coils are hard to reach, it often makes sense to do them all. The labor cost is already there. Coils that are the same age have the same wear. On easy-to-access coils, just replace the bad one and watch the rest. Use dielectric grease on connectors to keep moisture out. Stick with brands like Denso and NGK. Cheap imports often fail early. Now we have covered the ignition side, but there is another system that can copy these exact same symptoms. And that brings us to the fuel side of misfires. Keep watching because the parts coming up are ones most people never consider. And remember, numero uno is still ahead. Number 11 is the fuel delivery system. Most people think the fuel system either works or it does not. They assume if the car runs, the pump is fine. But fuel problems that only show up under load are very common. A weak pump might hold pressure at idle but collapse when you floor it. The symptoms look exactly like ignition problems. Hesitation on acceleration, misfires under load, power loss on hills. This sends mechanics down the wrong path, replacing coils and plugs when the real problem is fuel starvation. The trick is to test fuel pressure both at rest and under the conditions that cause symptoms. Idle pressure can look normal, while rail pressure collapses under demand. Test it during a hard acceleration or hill climb. That catches problems idle testing misses. To fix it, you might need a new pump, new filter, or a lift pump in severe cases. Be careful with aftermarket fuel parts. Cheap systems can cause pressure swings that make things worse. Your fuel pump might be working perfectly, but there is another component that decides exactly how much fuel reaches each cylinder. When this part silently degrades, your engine can develop misfires that are incredibly hard to diagnose. Number 10. Fuel injectors. Injectors squirt exact amounts of fuel into your cylinders. When they clog or fail electrically, they cause misfires that resist every other repair. Carbon, varnish, and dirt clog the nozzles. Bad fuel or water wrecks the inside. On the electrical side, bad wiring, blown fuses, or computer problems can shut injectors down even when they are physically clean. Here is something technical but important. Injectors have something called dead time. This is the delay between when the computer tells the injector to open and when fuel actually sprays. Dead time is usually around 2 milliseconds. That sounds tiny, but it matters. At very low pulse widths, during light throttle, dead time eats up most of the injection event. This can cause lean misfires during quick throttle adjustments. No other test reveals this. It drives people crazy because the misfires seem random. Basic tests like resistance checks and listening for clicks do not show spray pattern problems or dead time issues. For serious problems, a pro can bench test them to check flow and spray quality. Certain BMW engines need injectors coded into the computer. If new injectors are not properly programmed or indexed, misfires continue even though the parts are perfect. You need dealer tools for this. For mild deposits, fuel additives with PEA chemistry work well. Products like BG, 44K, and Chevron Techron get good results. Seafoam and Lucas work for light cases, but heavy deposits need ultrasonic cleaning. Heads up though, strong cleaners can shake loose gunk that clogs things up at first before getting better. Now your injectors might be perfectly clean, but there is another way air and fuel can get out of balance. When this happens, your engine goes lean in ways that set no codes and leave you chasing ghosts. Number 9. Vacuum and intake leaks. When air sneaks into your engine through cracked hoses or loose clamps, it throws off the fuel mixture and causes lean misfires. This is frustrating because it often sets no codes until real damage happens. The problem is simple. Air coming in after the mass airflow sensor is invisible to your computer. The computer thinks there is less air than there really is. It does not add enough fuel. The mixture goes lean and misfires happen, especially under load. For turbo cars, pressure tests the intake at full boost because many leaks only show under pressure. For regular cars, spray carb cleaner around intake joints while idling. If engine speed changes, you found a leak. Smoke machines show exactly where air is escaping. Watch out for aftermarket intakes installed without proper tuning. Wrong clamp torque and bad hose materials cause leaks and misfires. We are almost halfway through. These next parts are where things get more serious. And remember, the part at number 1 is the one that makes all of these other parts look broken when they are not. Stay with me. Number 8 is internal engine compression. Compression is what makes your engine run. When internal parts wear, they steal compression and your engine loses power. This happens so slowly, most drivers never notice until misfires get severe. Early signs include longer cranking to start, especially when cold. Then comes rough idle, weak throttle response, and less power under load. The engine might run better once warm because metal expands and seals better. Head gasket failures show low compression in neighboring cylinders plus coolant loss or overheating. Burned or bent valves mean pulling the head to fix. Worn piston rings show up as oil burning, blue smoke on startup, and compression that improves when warm. When spark and fuel checks come up empty, compression testing finds mechanical problems. A dry compression test gives you a quick answer. Add some oil and test again. If the numbers jump, your rings are worn. A leak down test tells you where the air is escaping. A bore scope through the spark plug hole lets you see valve condition, piston tops, and carbon buildup without pulling the head. But sometimes compression is fine and the engine is mechanically healthy, yet misfires still happen. That is when a tiny sensor starts lying to your computer. And when this sensor lies, it looks exactly like a fuel or ignition problem. Number 7, the mass airflow sensor. The MAF sensor measures how much air enters your engine and tells the computer how much fuel to add. When this sensor gets dirty, it sends wrong information. The computer makes fueling mistakes that look exactly like injector or coil problems. The sneaky part is a dirty MAF can cause real problems without ever setting a code. The readings are off just enough to cause misfires, but not off enough for a code. MAF sensors get dirty from bad air filters, oil vapor from the crankcase, and moisture. Cleaning is easy with dedicated MAF spray. Remove the sensor. Spray without touching the delicate element. Let it dry completely. Reinstall carefully. If cleaning does not help and live data shows strange readings, replace the sensor with OEM or quality aftermarket. For turbo cars, make sure intake connections downstream of the MAF are tight, so measurements are accurate. Tool quality matters for diagnosing sensor issues. Basic adapters and phone apps sample around 30 data points per second. Professional scanners hit around 100. Fast sampling catches quick misfires that cheap tools miss. Now sensors can cause big problems, but there is a cheap little valve hiding in your engine that nobody ever thinks to check. When this valve fails, mechanics replace dozens of other parts before anyone figures it out. Number 6 is the PCV valve. The PCV system controls crankcase pressure and returns blow-by gases to the intake. When it fails, it can stick open and create a vacuum leak. It can stick closed and build pressure, or it can clog completely. Any of these messes up your vacuum, dumps oil vapor into the intake, fouls your plugs, and looks exactly like ignition or fuel problems. This cheap little valve is easily the most overlooked part in the engine. When it fails, mechanics often replace dozens of other parts before anyone thinks to check it. Check it by pulling it out and shaking it. You should hear a rattle. Make sure air only goes one way through it. Check the hoses for gunk. On modern engines with integrated PCV systems, smoke testing might be needed. In some high-mileage cases, a new PCV valve fixed chronic misfires that resisted everything else. But in other cases, blaming the PCV distracted from harness damage or timing problems that were the real cause. Only 5 parts left. These are the ones that cause the most frustration because they are expensive and hard to diagnose. But number 1 is the one you really need to hear. It explains why so many people waste money replacing parts that were never broken. Number 5, engine position sensors. This means the crankshaft sensor and camshaft sensor. The crankshaft sensor tells the computer exactly where the pistons are and how fast the engine is spinning. This information times your spark and fuel injection. The camshaft sensor works with it to manage valve timing. A complete crankshaft sensor failure means the engine will not start, but weak or noisy signals corrupt timing just enough to cause misfires that come and go without setting codes. Beyond the sensor itself, check the reluctor ring for damaged teeth. That is the toothed wheel the sensor reads. Make sure it is mounted tight with the right gap. Check wiring because sensor replacement alone rarely fixes problems when the wiring or mounting is the real issue. Now, sensors can fail on their own, but there is something deeper inside your engine that slowly wears over tens of thousands of miles. When this goes wrong, the symptoms look exactly like a bad sensor or ignition problem. Number 4, the timing chain and tensioner. Timing chains, guides, tensioners, and variable valve timing phasers should last a long time, but high mileage, bad oil, or defective parts cause wear. This wear throws cam and crank codes, startup rattle, and misfires under load. The danger is this wear happens gradually over tens of thousands of miles, while creating symptoms easily blamed on sensors or ignition. Before committing to a big timing job, gather evidence. Look for correlation codes that survive sensor changes. Listen for chain noise at startup. Check for metal on oil drain magnets. Real examples show how frustrating this can be. A 2008 Cadillac CTS came in with a broken timing chain. The overhaul fixed the main problem, but the car still had an idle shutter. Further inspection revealed vacuum leaks and worn motor mounts. Timing failures often trigger cascades of other problems. Chevy Camaro owners with the LLT 3.6 V6 engine often panic when they see P0300 random misfire codes. Forums are full of timing chain scare stories, but experienced mechanics guide them to check spark plugs and vacuum leaks first. Many times the timing chain is fine, and the problem is something much simpler. On some BMW engines, diagnose causes problems. Diagnose is BMW's variable valve timing system. When the oil delivery or pump fails, it creates tiny timing errors. These cause misfires while compression looks normal. You need an oscilloscope to find this. We are in the top 3 now. These last few parts are what separate people who waste thousands from people who fix their car right the first time. Number 3. Intake valve carbon buildup. This only affects direct injection engines. In direct injection, fuel sprays straight into the cylinder instead of the intake port. This means fuel no longer washes the back of the intake valves. Without that cleaning, soot, oil vapor from the PCV system, and exhaust crud from EGR bake onto the valves over time. BMW owners with N54 and N55 engines, especially 2007 to 2009 335i and 335xi models, deal with nasty carbon buildup that you have to walnut blast to clean. This is one of the nastiest problems in modern engines because it builds up for years and then causes misfires that resist conventional repairs. Fuel additives cannot fix this because fuel never touches the valves. Professional walnut blasting is the solution. They pull off the intake manifold, blast the valves with crushed walnut shells, and vacuum everything out so nothing gets into the cylinders. For prevention, oil catch cans capture vapor before it reaches the intake. Shorter oil changes with quality synthetic reduce contamination. Good fuel with strong detergents keeps injectors clean. This all slows the buildup, but will not fix carbon that is already there. Now, carbon buildup is nasty. But there is another part at the very top of your engine that silently kills spark plugs and coils from the outside, and most drivers never even know it is leaking. Number 2 is the valve cover gasket. The valve cover gasket seals the top of your engine. It also includes tube seals around each spark plug hole. When these seals age and crack from heat, oil seeps into the spark plug wells. This oil silently kills plugs and coils from the outside. Drivers replace plugs and coils multiple times. The misfires keep coming back. Nobody notices the oil pooling at the bottom of the plug wells. A BMW example shows this clearly. Recurring coil failures were traced to oil contamination in the plug wells. The symptoms hid the real problem. Replacing coils did nothing until someone fixed the leak. When you do the valve cover gasket, replace all tube seals at the same time. Clean plug wells thoroughly before installing new parts. Apply dielectric grease to connectors to block moisture. And now we arrive at number 1. This is the part I told you about at the beginning. The one that makes everything else in this countdown look broken. The one that mechanics say causes more misdiagnosed engine problems than any other component. The one that 99% of drivers never think to check. Coming in at number 1 is the electrical system. This means connectors, wiring, grounds, and battery terminals. This is the ultimate silent killer. It does not fail by itself. Instead, it makes every other part look like it failed. People spend thousands of dollars replacing coils, sensors, and injectors. The real culprit is a corroded connector, a loose ground, or a heat-damaged wire sending garbage signals. Think about this. Every single sensor in this countdown depends on clean electrical connections. Every ignition coil needs proper voltage. Every fuel injector needs clear signals from the computer. When one connector corrodes, when one ground comes loose, when one wire gets damaged by heat, the symptoms perfectly copy a failed part. This is what happens in millions of cars with mystery misfires. Electrical connections slowly build up resistance from corrosion and heat. This resistance drops voltage and corrupts signals. The result is random misfires that appear and disappear based on temperature and humidity. Scan tools show codes pointing at sensors and coils, but the real problem is invisible because nobody checks the wiring. Mechanics have seen this over and over. They replace crankshaft sensors and coils multiple times. The problem never goes away. Then someone cleans the battery terminals and ground straps and everything works perfectly. This is why the electrical system is number 1. It is the part that makes all the other parts look guilty when they are not. If you take nothing else from this video, remember this. Before you replace any expensive part, check the battery terminals, clean the connectors, verify the grounds, inspect the wiring harness for damage. Because very often the problem is not the component, it is the wiring feeding it. Good troubleshooting means cleaning connectors with electronics cleaner, applying dielectric grease, looking for wires that rub, and checking for voltage drops on power and ground circuits. Computer problems are way less common than wiring problems. Driving with misfires is risky. Raw fuel in the exhaust kills your catalytic converter. A P0420 code usually means your converter is already toast from misfires, though sometimes it is just slow oxygen sensors or exhaust leaks. Real converter damage costs thousands. Misfires also burn more fuel. The vibration stresses mounts and loosens fasteners. Rich misfires water down your oil. Lean misfires under load risk detonation and engine damage. Severe misfires can trigger limp mode in traffic. The smart approach is simple. Read trouble codes first. Check mode 06 data if your scanner can. Start with easy tests like swapping coils, reading plugs, cleaning the MAF, and checking fuel pressure. And before you replace anything expensive, check the battery terminals, clean the grounds, and inspect the wiring. When you replace a part, fix what killed it too. Repair leaks, clean connectors, replace damaged seals. Now you know the 14 parts that silently cause misfires. More importantly, you know that number 1, the electrical system, is the hidden culprit that makes everything else look broken. Check it first. Check it every time, and you will stop wasting money on parts that were never the problem. But here is something that might surprise you. Remember number 10 on this list? Fuel injectors. There is one specific driving habit that most people do every single day that destroys injectors faster than anything else. And the scary part is that once the damage starts, cleaning will not fix it. The injector is toast. I made an entire video breaking down exactly what this habit is and how to stop doing it before you kill your injectors. If you want to protect your fuel system and avoid those expensive misfire repairs, that video is right here on screen. Watch it next. If this video saved you from a misdiagnosis, give it a thumbs up. Subscribe and hit the bell so you do not miss the next one. Drop a comment and tell us which of these 14 surprised you most. Let us know if you ever had a mystery misfire that turned out to be a wiring problem. We read every comment. Until next time, drive safe and keep that engine running smooth.